Okay, welcome to a new topic. This time it's all about trigonometry, and trigonometry is all about triangles. So we're going to start by looking at sine, cosine, and tangent. You've probably heard of those things before. You've probably used them in the past, maybe in National 4. But we're going to have a look about into the graphs of these particular functions. Um, so we're going to start just by going over what actually sine, cosine, and tangent actually are, and then we'll start to talk about their graphs. So let's have a look. So we're going to start with this circle. Okay, and I'm going to show you an interactive version of this in a second. But this really is where sine and cosine come from. So if I show you this version of it, so you can see I'm able to move this around. Just take a look at the circle to start with. It's a circle of radius 1. So we can see a blue line there. That line is 1. We call this the unit circle. And in that case, unit just means 1. It's got a radius of 1. And we can look at some of these lines that are appearing here. So, for example, if I set my line like this and my mouse to this point, the angle of this triangle is 44 degrees. So you might be able to see at the top of the screen, it says cos 44 degrees. It means this angle right here in the middle, okay, where I'm moving my mouse now, this angle is the angle being changed. So it's 46 degrees, now I'm moving it up to 52. Okay, so that's the angle that we're interested in. As the angle changes, the length of this line, of these two lines, change. So notice how, as I move the angle, how long these lines are changes. Yeah. So it makes sense, at this point here, the blue line is really small. It's only 0.1, whereas the green line is really big. It's 0.99, so it's nearly a full length. Okay, and again, I can move it around here. The blue line's big and the green line's small. And this is what sine and cosine are. So sine of 43 degrees is just asking you what is the length of the green line. So the sine of 43 degrees is 0.682. Okay, that's all we really mean by sine and cosine. Cosine of 43 degrees is 0.731. Okay, that is the length of the blue line when this angle here in the middle is 43 degrees. We can have negative lengths. So for example, here you'll notice that the cosine value is a negative. All that means is that we're going in this direction. So you can see there's like an axis has been plotted here. So the middle of the circle is the origin, is the point 0, 0. So if we have a triangle that's pointing this way, what we have is a negative value for cosine, and we can have a negative value for sine as well. So again, notice how because the triangle's pointing down, the sine value is now negative. This is what sine and cosine are. Tangent is dead simple. It's sine divided by cosine. So if you got a calculator out and you did 0.695 divided by 0.719, in other words, the blue divided by the green, you would get the red answer. You would get 1.036. So that's what tangent means. It's just the sine divided by the cosine. Okay, so if we jump back to this, we can see that this is just a useful diagram just to help you remember that. And again, we've got cos theta there. Theta just is a symbol we use quite often to talk about an angle. So all this means is if this right here is the angle theta, this length would be the length cos theta, and this height would be sine theta. Okay, so that's a kind of brief overview. Don't worry if not all of that sunk in. What's important is that we understand how these graphs actually look. So I'll show you how this graph actually looks, right? So this is a sine graph, and notice how if I was to plot the graph, which is what's happening on the left-hand side, it makes this quite pleasing shape. This is a sine wave. So this is the interesting thing about these this trigger about can't even speak about trigonometry. what you get is these really pleasing shapes. So those are the graphs we'll look at. And again, this is used to model all kinds of situations. So that on this website, they've obviously got an example here of like using a spring. So if you wanted to model how a spring works, you would use perhaps a sine function to model that. And again, you can see here, that's a wave function, isn't it? You spring it up, we've got a high amplitude here, and then it's starting to dip down, but you can see how it's similar to this. Okay, so a sine wave would be a nice way to model anything that has this kind of feature. So this is the sine graph. Okay, it's got this really distinctive shape. It starts at 0, it goes up to 1, it then goes back down, and then at 180 degrees it's back to 0, and then it goes back down to -1, and then it goes back to here at 0 at 360. Okay, so that's what a sine graph looks like. Okay, I'm also going to show you a cosine graph. So a cosine graph is very similar, except instead of starting at the bottom and going up, it starts at the top and goes down. So it's a sort of bucket shape like this. So sometimes people think of like sine as like a hill going up and then a valley, whereas cosine, you start up at the top and it's just this bucket shape that you've got. The tangent graph is a slightly strange looking graph for reasons that I'll go into a little bit more in a different video. But basically what happens is it starts here, it goes up, and as you get closer to 90 degrees, this value gets higher and higher, and then it sort of pops out the other end over here. Okay, I'll talk more about the tangent graph in a different video, but I just thought I'd show it you up front here, just so you've got an idea of what the three graphs look like. Okay, so we're going to have a little play around and look at some definitions. So the first definition I need you to know is something called frequency. Frequency is how many times the graph repeats itself. So when we're talking about sine and cosine, that's how many times it repeats itself in a 360-degree period. Okay? Now for tangent, it's a 180-degree period. So let me show you this. How many times does this sine graph repeat itself in a 360-degree period? Well, it just does it. It just does it once. Okay, so that it doesn't repeat itself. It's simply once. Okay, so it has a frequency of 1 here, but we can play around with that. Okay, so if I sort of start doing some plotting myself. Okay, so what I'm going to do here is plot the graph y equals sine x. Okay, and then we'll play around with that. Okay, so I might have to zoom in a little bit. It's because I didn't put degrees on. Okay, so here we go. This is the sine graph plotted for you now. Okay, I'm just going to get rid of these points because we don't need to see these. Okay, so we've got a sine graph here. Okay, now what I'm going to do, okay, is I'm going to, instead of putting x in here, I'm going to put 2x, and I want you to see how it changes. Okay, so notice that when I put 2x in, it's changed. It seems to be repeating itself more often. Let me make it 5 and let's see what happens. Can you say the sine wave's getting squished together? Really what's happening is it's repeating itself more and more and more. Okay, so if I do something like, 100x, you might think it's going to be very close together. Yeah, I'd have to zoom in quite a way to start to even be able to see this. So just going back to our original sine x. So we've got this, nice nice curve here. It repeats itself once. It does one, it starts here, it goes up, it goes down, and it goes back to the start once in a 360 period. If I make this 2, it goes up, down, back to where it started, up, down, back to where it started. In 360 degrees, it repeats itself twice. Okay? You might be getting the idea now. If I make this 3, it goes up, down, back to the start, up, down, back to the start, up, down, back to the start. It repeats itself 3 times. You may have noticed the number of times it repeats itself, the frequency is the number in front of the x. So if I made this 10, it should repeat itself 10 times. Okay? Oh, sorry, these have all started to show again. Don't need these. Let's make it a bit clearer. Oh, I'm just going to delete this function. There we go. Right, okay. We've got y equals sine 10 of x. So this should repeat itself 10 times. So let's just check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 sort of hills, back down, back up here. So it repeats itself 10 times between 0 and 360. That's what we mean by frequency. So I hope that's been clear enough. Give you an idea of what frequency means. It's just how many repetitions in 360. And this is true for cosine as well. So again, if I just make this cos, okay, notice that we use sine like sin, and cos is like the shorthand when we're actually typing this out. And on your calculator, you'll see a sin button and a cos button. It's actually sine and cosine. Again, look, this is the bucket shape, but it repeats 10 times. So I put here it's the number multiplying x. The frequency. The period is the amount of degrees it takes to complete one cycle. So if I go back, if I do a sort of simpler example here, if I just make this 2, you can see how many degrees does it take to do one cycle? So that's from, in the case of the cosine function, top of the hill, down, back to the top of the hill. Okay, well, it takes 360 degrees to do 1. So it's got a period of 360 degrees. If we change that, say we made this 2x, the period would be 180. And the reason for that is you get one sort of cycle of cos, which is starting at the top of the hill, to the bottom, back to the top. That all takes place in 180 degrees. So it's got a period of 180 degrees. Okay? Just to make sure that's really sunk in, I'll go back to 10. So one period would be 36 degrees. Again, if I zoom in, that's a bit clearer. All we're looking for one period is for one cycle. So here, from the top to the bottom, back to the top. You can't quite see it on the axis, but that would be 36 degrees there. Why 36? Because that's 360 divided by 10. And we already know that there are 10. If it's got 10x in there, then it's got a frequency of 10. Okay, so a couple more definitions that I'll show you. The amplitude is the height of the graph. So if I go back to our just the normal graph here, the height of the graph, the maximum height is 1, and the lowest point is -1. So the amplitude is 1. Let's mess around with the number in front of cosine here. Let's make it 2. Can you see how we've not squished the graph, but what we've done is stretched it? And you can now see that the amplitude is 2. The highest point, the top of the hill, is 2. Okay? Right, I'll make this like 5 sine. So we'll just have a look at a sine function to see that it works. Again, I made it 5, which is why the maximum point here is 5. Okay? And the lowest point is -5. So that's the amplitude. Okay, and again, it's the number in front of sine x or cos x. Okay, there's another definition, which is the phase angle, and this is how far right the graph has been shifted. So I'll show you that in practice. It's the number being taken away from x. So again, I'll just go back to the usual sine graph. So sine of x looks like this. If I take 10, I'll just put degrees in. If I take 10 degrees, what happens is the graph shifts to the right 10 degrees. So instead of crossing at 0, or instead of starting at 0, it starts at 10. Okay. If I was to take 50, right, what's going to happen is this graph's going to shift over, and instead of starting at 0, it's going to start at 50. Do you see what I mean? The sine wave is starting at 50 degrees. We don't have to take away, we could add, but that'll just have this a slightly different effect. So if I add 10, say, you can see it's going to shift me to the left by 10. So instead of starting at 0, I've started there. So this is called the phase angle. And that's really adjusting kind of where the sine wave starts. Okay, so we're nearly done on all these definitions. There's just one more that I want to show you, and it's this one here. It's the vertical translation. So we've talked about shifting left and right. Now we're going to talk about shifting up and down. And it works in a similar way. Let's just go back to our normal sine graph. So here we go, we've got a nice sine curve here. If I add 1 to this, it shifted the whole graph up 1. So you can see here, instead of crossing the y-axis at 0, it's crossing the y-axis at 1. Okay, so everything just shifts at 1. If I make that plus 6, okay, it's going to be off my screen because I'm going to have to move up. And we can, take 2, for instance, would just move it down. So you get the idea. So we can adjust things there. We can do all this at once. So we can do something like 2 sine 3x minus 2. Okay, so what's that doing? It's giving an amplitude of 2, and it's giving it a frequency of 3. So this repeats itself 3 times in the 360-degree period. The sort of height is 2. Now we've got to be careful here because you can see that the height, the amplitude is 2, because if we start at minus 2 and get as high as 0, and again we can see that we've shifted. So again, this can be these curves can be as complex as you want them to be. So I appreciate that's a lot to take in. I'll give you a lot of definitions there. The main thing is going to be practicing and referring to these notes and the notes that you've got in the system as well to help you get through it. This is what it looks like in the test. So here you've got a graph. You're told that you've got a sine b of x, and it wants to know the values of a. Okay, so a is the number timesing the sine. So let's go back to our definition. The number multiplying sine of x or cosine of x is the amplitude. So when it says state the value of a, it wants to know the amplitude. Well, the amplitude is 4. Okay, so this number here is 4. This is the graph y equals 4 sine of something x. Now this something is the frequency. How many times does it repeat in a 360-degree period? Well, it goes once, twice, 3 times. So this is a sketch of y equals 4 sine 3 of x. Again, we needed to know where to find amplitude and where to find frequency. So it's about learning those definitions. Okay, another one. Again, these are very similar, aren't they? A and B. A is our amplitude. It's 5. B is our frequency. Remember, it's in a 360-degree frequency. So we need to be careful here because this graph doesn't even go to 360. It goes once, twice, so it does it twice in a 180-degree period. So if this carried on going like this, that's another, and that's another. It's a bit crude the way I've drawn it here, but B would be 4, because remember 180 is half of 360. So to do 360, you would have had to have done 1, 2, 3, 4. So B is 4. Okay, so this time we're not told whether this is sine or cosine or what. We're just told it's a function. We've got this. It says state the period in degrees. So remember, the period is how long does it take to repeat itself. So, okay, it's not repeated yet. It's not repeated. Here we go. At this point here is when it starts repeating. So it's whatever this distance here is. Now this point's not marked, but we've got 180, 90. So I reckon this is going up in 30s. Okay, let's just check that. 90, add 30 is 120, add 30 is 150, add 30 is 180. So this is going up in 30s. So this point here is 120. So the period is 120 degrees. It repeats itself every 120 degrees. Here's the graph of y equals a sine of x plus b. Okay, find the values of a and b. A is the amplitude, which is 3. Okay, now recall, okay, this, when it's sine of x take b, x take b would be how far it shifts to the right. So add b would be how far it's shifted to the left. So let's just have a look. The sine graph should start at 0, but what's happened is it's shifted 40 in this direction. So if you want to shift to the right, you need a negative. Okay, so that just goes back to our definition. If I show you that, okay, sorry, it's over here. It's the number being subtracted from x to go right. So to go to the right, you need to subtract. So here I've gone 40 to the right, so this would be sine x take 40. And we've already said that a is 3. Okay, so this is the graph. So the value of b would be minus 40. Okay, so those are some past paper questions. Like I say, the only way you're going to get really solid and fluid with this would be keep practicing, keep having a go at these sort of things, and refer to notes. You're not going to remember amplitude and frequency and periods and phase angle. You're not going to remember all this just straight away. You're going to have to see a question and look it up, and it's only by doing more and more that you'll start to get it.